Okay, so good afternoon, ladies and gentlemen. So this is a continuation of trigonometry, as we talked about, and I know some of you are still waiting for these videos to be released. So we are we are now in our second video of the same trigonometry. So now we'll continue from where we ended from our first video, which was talking about how can we solve trigonometry using the method of right angle triangle, using the trigonometry ratios such as the sine, the cosine, and then the tangent. So if you haven't watched that video, I actually encourage you to go back and watch the video so that you can actually understand what you're going to do right now. So therefore, we continue now for the second phase of the tutorial under the topic of trigonometry. So therefore, in this video, we will look at also a second method which we are calling non-right angle triangle, which is okay. So in this type of trigonometry, so it's going to shift a little bit from what we did previously or in the other videos. So you can see that this is a non-right angle triangle. So therefore, the methods that will be used to solve this kind of equation that are attached to non-right angle triangles will be a little bit different, but the fundamentals are the same that we talked about in our first tutorial. So therefore, we'll start with the sine rule, which is also used under non-right angle triangle. So now, here is a simple scenario. When should you use the sine rule? When should you, how do you know that I'm going to use the sine rule? Okay, and people should be able to understand that if you are going to use the sine rule, then the triangle that will be given by the examiner or any question that you're going through is not a right angle triangle. So you have to kind of differentiate which one is a right angle triangle and which one is not a right angle triangle. So after you differentiate, then you'll be able to know when you should apply the sine rule. So therefore, when we say non-right angle triangle, we mean that the triangle is none of the angles equals to 90 degrees. So that's the meaning of this statement over there. So what you kind of understand is that the angles that you'll be dealing with, none of them is a right angle triangle. Therefore, that should be actually understood from now on. So when are you supposed to use the right angle triangle? I mean, when are you supposed to use the sine rule? Okay, so the sine rule can only be used when you are given one side and the three angles. So you must be able to understand that we're using the sine rule as a formula to find a solution to a non-right angle triangle. Then these are the conditions that you should actually bear in mind when you're solving trigonometry under the non-right angle triangle. So therefore, you'll be given one side and the three sides. So here is an example. So let's say, for example, I'm given this side CB, which is one side, and then all the three angles. Okay, so I'll have an angle. Let's say, for example, for the sake of the this condition, we say 20, 30, and 40. Okay, so that's kind of a simplified statement there. So one side, and then they will give you the other three sides. Okay, yeah. Now, second, when also should you use the sine rule? So the sine rule can also be used when you have got two sides and also one angle which is opposite to those two given sides. So what does this condition mean, or how do you identify that? Okay. Okay, so now one side, meaning for instance two sides, then I can have that number like 5 centimeter, then I can also have 4 centimeter. Okay, so now one angle opposite to one of the two given side. Okay, so please don't forget one angle which is opposite to one of the given sides. Okay, so ensure that you understand that point, that I'll be given two sides and then one angle. This angle should be opposite to any of the those two given sides. So once you understand that those are the two conditions, then in this example, to clarify on this statement, then it simply means two sides, we have two sides there, then one angle. Okay, so one angle, we can have an angle somewhere, angle C somewhere over there, then we can just say this is 70 for the sake of simplifying the statement, 70, and then two sides. So when you look at 70 over there, the opposite of this angle is down to the side of AB. So the opposite of angle 70 is the side which is 4 centimeter. So once you actually come across this kind of a triangle, then you have to bear in mind that I have to apply the sine rule. Okay, and that's how you get to understand how should I use the sine rule and when should I use the sine rule. So when should you use the sine rule is you look at the two conditions, then if the triangle given or the question given by the examiner satisfies these two conditions, then apply the sine rule. So we have got an example down here, so we are going to solve through the example so that you'll be able to understand. Of course, you can also, you know, try to solve on your own, and you can comment which paper you're solving, and then we'll drop down this video on YouTube. So once you get any past paper 2010, 2015, 2016, 2019 or 2020, you can comment if concerning what we are actually trying to learn over here. So once you get stuck, you can actually comment below and then we'll get to help you. Okay, so let's move on to the examples. Okay, so ladies and gentlemen, upon now understanding the conditions and the sine rule, but before we get to find out how exactly can we apply the formula of the sine rule. Now the sine rule, here is the formula. Okay, here is the formula. Okay, so let's imagine that this is a triangle. We have A, B, and C. So once you are given this triangle, then bear in mind that the triangle should not be a right angle triangle. We have gone away from that concept of using a right angle triangle. We are using a non-right angle triangle. So none of the angles is a right angle triangle. Okay, so the angle is more than 90 or less than 90. So therefore, if you want to know how we can apply the sine rule, then this is a formula. Okay, so you can have this angle which is pointing down here, and then the opposite of angle A, we can actually arbitrarily or just literally assign a small letter A just to kind of understand the relationship, like A equals to small a, and then the opposite of angle B is facing to that side. We can also put small letter B. Then the opposite of angle C, we can also put small letter C. So once you get to understand how to actually relate the two relationship between the angles of a triangle as well as the opposite of that angle, which is also the side. So therefore, the formula is as follows. So we are going to say the sine of this angle, remember the function of the angle you're using is the sine. So the sine of this angle A over its opposite. So it's kind of a ratio. A ratio is angle A and then its opposite. Okay, so ladies and gentlemen, so let's have an understanding of how you can come up with the formula of the sine rule, how to use the sine rule. So the sine rule, like I mentioned in the beginning, that you get it's used to solve non-right angle triangle kind of problem under trigonometry. So what the formula, the way you come up with the formula is when you have this angle somewhere there, then this angle is facing down here, so you have small letter a. Then the opposite of this angle is pointing to that direction, so you also have small b. The opposite of this angle c is pointing to that direction, which is small c. So therefore, the way you can come up with the formula is just actually the relationship between that angle and its opposite. Okay, so the opposite of angle A divided by its actually the size of angle A. So you do that throughout angle A, angle B, and angle C, and then depending on which ratios are actually available in the given formula, then you choose which one of those you are going to use. So you don't use everything in the formula, but you get to compare what the question is asking you to actually solve for. So therefore, let's kind of see how the formula looks like. So you say sine A over the opposite of sine A, which is small a, then sine B over the opposite, its opposite, which is a small letter, then sine C over small letter c. Meaning, in the formula of sine rule, we've got two equal sign, but this doesn't make sense. Okay, in an equation we only have one equal sign. So depending on which of these ratios are actually available in the question, or rather the diagram that have been provided by the examiner, then you get to choose two pairs of the ratios. Okay, if this does not exist, you use this one. If this is not actually complete, you use this one. If this is not there, you use this one. Okay, so that's how you get to use the sine rule formula. So therefore, now let's do the actual example of the sine rule. Okay, so here is an example. We've got, they are saying, given triangle, by the way, this symbol represents a triangle. So therefore, given this triangle below, calculate angle B as well as the distance from A to B. So we are going to calculate the angle over here, and then the distance between A and B. So the distance from A to B, so we need to calculate. Okay, so now in this scenario, you know that you only have angle A and the opposite of angle A, and then you've got angle B, which the question is asking for, and then angle B has also its opposite sign. Therefore, what you're supposed to do is say, write the general formula for the sine rule. Okay, so sine A over small a equals to sine B over small b. Okay, now sine C over small c. Okay, so now what you're supposed to do, just see what you have been given in the question and then plug in the actual variables or parameters that you have in the formula. So the first principle or the basics is that, first of all, you are looking for the angle B. So this one automatically we are going to use it. Okay, and then now let me see what is the complete ratio in the diagram. So I've got angle A and its opposite. So therefore, I'm going to use this and this. So I'll not need the sine C and its side. So therefore, what you need to understand is that you are not going to use everything in the formula, but you get to actually plug in the actual numbers of what is available depending on the question. Okay? So now let's start solving.